Yes, welcome to our Coding Aviation training series. In this video, we continue from where we left off. If you remember, we last calibrated the compass in clear weather. Now in this video, we move on to the first flight. We will perform the first flight of our drone in stabilize mode, but before that, we will cover radio failsafe, and before that, we will set up the flight modes on our drone. While setting up the flight modes, we will configure the alt hold, stabilize, and position hold modes. Additionally, we will discuss the auto-tune mode. The auto-tune mode will be a bit different from the other modes. When we get to the flight setup screen, I will explain all these modes in more detail. Now, before that, let's list all the steps we'll be taking. In this video, the steps we'll follow are: first, let's connect our drone with a cable. After connecting our UAV, let's establish the connection through the COM24 panel on my computer at 115/200 baud rate as usual. I couldn't connect it. I'm trying again. After making the connection, my UAV currently doesn't see the GPS. GPS no fix. Connections are being prepared here. When we get to the setup part, we hadn't set the initial parameter. Let's set it now. My UAV has 15-inch propellers and a 5S battery. I wrote these down here. My battery cell is 4.2, meaning the maximum voltage for each cell of my battery is 4.2 and the minimum voltage is 3.3. When I said calculate initial parameters, it calculated and displayed these parameters for me. It says to write them to the flight control board and mentions after the test fly. After the first test flight, it tells us to adjust the ATCR Mixman to 0.5 and also the PSC-ACZP and MOT THST hover values here. I want to take notes with my pen. Yes, I'm taking notes of these values with the pen I got from the external source. Here it tells me to set the ATCR Mixman to 0.5 after the first flight.
He said happy flights.
I confirmed. After confirming, what we need to do now is disconnect my connection here, unplug it, and reconnect it. I do this after every important parameter change. I'm waiting for my connection again.
My connections are ready. Now I will go to the motor test screen from optional hardware.
From the motor test screen, I will calculate set motor spin arm and set motor spin min. Now I'm connecting my UAV. After connecting the battery, I notice that my motors are powered. When we test motor A from here, the motor on the right should work according to the direction of my UAV. B, C, and D values will also move clockwise from this motor. Let's test A, B, C, D. I started B, I started C, I started D. It's that simple. Now, before saying test all motors, I set my throttle to around 10%. This is the value I want to arm and adjust. When I say test all motors, I notice that all motors are spinning at an equal speed. From here, I set my motor spin with a 2% tolerance margin to 12. I also set the motor spin minimum to be 3% higher than my arm minimum. Here, it automatically sets itself to 3%. I then select Change Throttle. After confirming, all the steps we've done here are complete. Now, where do I go after exiting optional hardware? Before setting up the flight modes here now. When we turn on our controller, it's important to know what we previously assigned to Channel 5 and Channel 6. Channel 5 controls our flight modes, and we will soon load the ARM command onto Channel 6. Normally, to ARM, you need to bring the two joysticks here diagonally. But I won't be using that. So now I'm starting to set my values. I've assigned this button to the 5th channel. And as you can see, I can monitor the changes like this. My first flight mode will be stable. The second flight mode here will be all-thold, and I'll set the last flight mode to posh-hold. No, I'll set the last mode to auto-tune. When I say save mode complete, my flight modes will be saved. Now, when I disconnect and reconnect, I will be able to see them through the interface. Yes. Right now, when I look at my UAV setup, I see that my UAV is disarmed, and when I follow the pre-flight checklist here, it says that the GPS is bad, I don't see any satellites, and my battery level is low. It also says that I have set the MOTSPIN arm and MOTSPIN min values incorrectly. So I immediately go back to the setup section. I select optional hardware. On the motor test screen, I set the motor spin min to 13%. After confirming, when I return to the status section, this issue should be resolved. Yes, once this issue is resolved, I can arm my drone. Now from the setup section, I go to the config section, and the most important thing to pay attention to in the config section is extended tuning. Here I need to change channel 6, RC6 option from do nothing to arm disarm. The current version is ArduCopter 4.5, so I select arm disarm 4.2 higher. When we say this, it gets written to the Pixhawk. Yes, it's that simple. Now, when I return to my main screen, the UAV is ready for its first flight. There are certain key points I need to pay attention to during the UAV's first flight. When I initiate the takeoff, there should be no vibration at all. In addition, if I see any vibration or oscillation values, I will reduce the ATC RAT PIT PID values by 50% and also reduce the ATC RAT RLL PID values by 50%. After ensuring that my UAV takes off perfectly and maintains a stable position in the air, I will switch to all-thold mode. That's how simple my procedures were. Now I'm making the necessary settings for the first flight. I go to the config section. From here, there are some values I need to set for the first flight in the full parameter list. I'm setting the MOTHST hover value. Yes, I've set my MOTHST hover value to 0.25. I click Write Params, Confirm, and it saves my parameter. Yes, I saw that ATC HDR Mixman is set to 0. This indicates the manual flight level of my throttle during all-thold control. It was already supposed to be set to 0. This setting is currently 0. After the process is complete, I need to increase this value to 0.5. All right, these are all the settings I need to adjust for the first flight. Now I will assemble the propellers and conduct the flight in an enclosed area. Yes, we have started filming for the first flight test of our aviation coding project. It is very important to take safety precautions during our first flight test. So we will be controlling our unmanned aerial vehicle. But in case it goes out of control, we need to be able to disarm it immediately, and wearing a helmet is crucial to prevent anything from falling on our heads. Afterward, for visibility, we also put on our safety vests. Now let's start our work. We connected the telemetry at a 57,600 baud rate.
Now, after making my connections, I can see that my drone is currently able to take off in stabilize mode. When we go to the setup section of my drone and enter the mandatory hardware part, an adjustment is needed. Here I remove the auto-tune mode and change it to stabilize. What I need to do now is ensure that the drone remains stable in that position after takeoff. If my drone exhibits any oscillation or vibration, I need to reconfigure the PID settings. The motors of my UAV have started spinning. Slowly, my UAV I'm taking off. As you can see, my drone didn't stay stable in the air. So right away, through my computer, there are some values I need to adjust here. Yes, after setting these parameters, I will start preparing for the takeoff of my drone. I'm starting.
I see there's still some instability, so I'll reduce my values by 50% again. At this stage, we repeatedly test our drone by changing its PID settings. After adjusting the PID settings of our unmanned aerial vehicle to the most optimal level based on our tests, it's time for position hold mode and auto tune. We have completed the PID settings of our amazing drone. Now we will move to an open area to conduct the flight tests of our drone. We have now completed the PID settings of our drone. Now we will proceed to its flight in an open area. While flying our drone in an open area, we will first lift it in stabilize mode, then switch to off-hold mode, and finally we will complete the operations of our drone.
First, we lift our unmanned aerial vehicle in stabilize mode.
We switch our drone to off-hold mode. We are switching our drone to push-hold mode. Great. We have completed all the procedures. The PID tuning of our drone is spot on. Now we're starting the test flight. Great. You have successfully completed all the steps up to this point, and we have successfully finished the PID software for our drone. Thank you for watching.